Madhu sir? Madhu sir? Madhu sir?
Hello, sir.
Sir, you can start, sir.
Okay. So very good afternoon. Am I audible?
Yes, sir. Audible, sir.
Okay. So welcome back to the afternoon session on IoT. So I would like to demonstrate two more use cases. One is like, controlling a device through IoT ThinkSpeak. And the second use case is like, I wanted to implement machine learning algorithm on the IoT data set. So these are the two use cases which I wanted to demonstrate in IoT session today. So let me jump into the topic without any delay. So in the morning, we have discussed about the various points related to IoT, and then we started talking about Raspberry Pi. And then we started reading data from Arduino, and we have uploaded the same data. So that is what I'm sharing right away. Now what I'll do is I'll go for the second use case, which is like, controlling a device through IoT ThinkSpeak Cloud using a mobile application. So as far as screen sharing is concerned, I'll also show you, using emulators and all, because I cannot show you my mobile phone screen, through this. Okay.
Madhu, sir. Sir, you are not audible, sir.
Hello, can you check
Yes,
now?
sir. Yes, sir. Yes, sir. Now it's okay, sir.
Am I audible? Hello. Yep.
Yes, sir. You're audible, sir.
Okay. So I wanted to, control a device. Say last time, just a couple of years back. So I did a project related to universal robotic arms. So there is a project from Denmark University, R&D lab, robotics lab. So there was a robotic arm, universal robotic arm, which was industrial based robotic arm. So they said they wanted to control that robotic arm from anywhere across the globe. Okay, that was the context of the project. So I just wanted to control it right away from Hyderabad. So from my workplace, I wanted to control that robotic arm. So which is in Denmark. So if you want to do that kind of use case, okay, if you want to control a device which is far away from you, okay, then obviously we have to use something like, IoT protocols. So by using IoT protocols, we can easily communicate. So with the device, if you want to control a device, you need to communicate with the device first, and then you can easily control it, right? So if you are unable to establish a communication between the device and you, obviously you cannot control it. So right away, my point is very simple. If you want to control, say if you're in a class, if a student is making some noise, so if you want to control that noise, okay, so you have to communicate first, right? So without communication, we cannot control it. So my point is very simple. I have to communicate and then I have to control it. That is my point. So there is a protocol in IoT which is very popular. For example, say when you look at WhatsApp, okay, when you look at WhatsApp, there was a communication which is relevant to it. So say in WhatsApp, you have, a sender and receiver. Say I wanted to send a message from here to the friend. Okay. So I wanted to share a message to my friend on my WhatsApp. So I'll be sending a message to the WhatsApp server. And what WhatsApp server will do? WhatsApp server will deliver that message to my friend. So based on the mobile number which I enter, right? So if you want to send a WhatsApp message, what you have to do? You have to select the contact first. So which is nothing but you're selecting the sender, you're selecting the receiver, right? So you will be selecting the receiver, and the WhatsApp server will be understanding to whom it has to send a message. So in between sender and receiver, there is a server which is connected in between us, right? So in the similar way, if you want to connect, say if you want to communicate with a student in the class, so you should be available in the class, right? Without you available in the class, you cannot communicate with that student. So it means that you have to establish a network first. So when you establish a network, then obviously we can communicate, right? So here in WhatsApp or when you look in Twitter also, if you want to tweet, so say all the followers will be able to get this tweet because when they follow you on the Twitter account, right? So which means that a Twitter server is able to manage all these requests coming in and out, right? So here also in IoT also you have the same context where you will be having a server which is hosted on the cloud. Okay, and that server will be able to send and receive multiple requests coming up. For example, say I'll show you one server which is open source. Hope my browser is visible to you. There is a server called broker.hivemq.com. So this is very popular server which is used in various IoT use cases, where this server will be able to receive and send data. Okay, say I wanted to send a device, I wanted to send a data to the device which is hosted, which is connected to this server. So which means that if WhatsApp server is on, then we can communicate over WhatsApp. So in the similar way, if the sender and receiver as connected through this server, then obviously we can establish a communication here. So the protocol is very simple protocol, which is MQTT protocol. MQTT protocol is a widely used communication protocol if you want to establish a communication between the devices when they're far away. For example, say, so as of now, I know ShareIt was banned in India, but if you look at ShareIt, when we are studying in BTech in 2010, 2009, so we used to share files through Bluetooth communication. So in Bluetooth, the transfer of data is very slow when you compare with ShareIt. But what is the technology behind ShareIt? The technology behind ShareIt is Wi-Fi. So through Wi-Fi, they want to use it. They used to share files and all. So when you compare with Bluetooth, the speed of the data rate is very much higher. So we used to have ShareIt, right, in between the friends or in between the entities. So there, what happened? So if you want to share a file, if the friend is very nearer, if you want to share a file, obviously you will be using ShareIt application, right? So if the friend is far away, say one friend is in Hyderabad, second friend is in New Delhi. So if you want to share a file, you cannot use ShareIt application there. So what you'll do there, you will be using Google Drive, or you will be using some Gmail, or you will be using some Dropbox. You will be using OneDrive in order to share a file if the friend is far away, which means that you have to use internet if you want to communicate with people far away. If you want to communicate internally, say, you can use something like share it, which is like intranet. So intranet and internet use cases are very important if you want to implement those kind of scenarios, right? So that is one important point which I wanted to highlight, like, so if you want to control a device, so make sure that you and your device are connected with server. So server plays a bridge between the user and the device here. So that server is nothing but MQTT protocol. So let me put that slide. Okay, so give me a minute. I'll open the presentation so that we can quickly talk about it.
Huh?
Okay, let me share my screen. This is. So MQTT protocol. Is my screen visible?
Yes, sir. Visible, sir.
Okay. So let's talk about quickly MQTT protocol. So my take on MQTT protocol. So MQTT is an alternate to HTTP protocol. So it is widely used in IoT use cases. So MQTT is nothing but message queue telemetry transport. So you can transfer your messages from any place to any place when you have internet connectivity. So that's the main intention of MQTT. So it is also open source. You can find the documentation on mqtt.org. So that is a community website of MQTT. So IBM made it open source. So this protocol was initiated by a company called IBM. So they made it open source. And now Eclipse Foundation is maintaining it. So the main important features related to MQTT is, like, it's a TCP/IP protocol. It works on TCP/IP. And the most important thing is like, the bandwidth is very low. Say if you want to use this MQTT in 2G, say in 2G or 3G, MQTT can able to transfer your messages from anywhere to anywhere. It's like, you can able to have a communication between two devices, or you can say you can establish a communication between device and a user. So using MQTT also, you can able to transfer messages like HTTP. So previously in the morning, we have discussed about how to use, HTTP protocol, right? So we have used HTTP REST API, to establish a communication between them, right? So you can also use MQTT protocols. So MQTT is also supported with ThinkSpeak Cloud. So you can use this protocol even. But the main important thing is like, HTTP requires heavy bandwidth when you compare with MQTT. So MQTT requires less bandwidth. So bandwidth is the usage of internet is also very important. So for less bandwidth applications, MQTT is widely used. It works on TCP/IP. And the code is also very small. So you can use C program or C++ program or Java program or Python program. So the code footprint is very small when you compare with HTTP. So it is ideal if you want to implement on processor, or if you want to implement on limited resources, you can easily use this MQTT protocol. So MQTT protocol is a communication protocol. So first, if you communicate, you can easily control. So that's the important point which I wanted to highlight. So you will have sender and receiver. So in WhatsApp also you'll have sender and receiver. So you will have publisher and subscriber. So publisher is an entity who publish the message, who sends the information, and subscriber is an entity who receives the message. So which is like receiver. So in WhatsApp, in Instagram, in Twitter, everywhere you see you have a concept of follower and following. So which is like a publisher and subscriber. So publisher is an entity who sends a message. If I want to publish a message to my device, so I will be the sender, device will be the receiver. If device wants to send some information, so device will be the publisher, I will be the subscriber. So if you look at the Instagram or if you look at the Twitter, you have a concept of followers, right? So right away, who are following you? Your friends are following you. But after 5-6 years, your curtain will be following you on Instagram. Your curtain will be following you on various social networking blogs, because subscribers are the devices from whom you information has to be shared. Say if I post something on Twitter, or if I post something on Instagram, immediately that data can be grabbed by the devices. So that the kind of communication can easily happen. Okay, so today only people are having Facebook accounts, Instagram accounts and all. But in the near future, all the devices will be more social. That is why people are talking about, being social. So when the digital devices are being social, then almost a majority of use cases will get try to solve around it. So here people use PubSub model. So in MQTT protocol, so you have a broker. So broker is nothing but server. So in MQTT protocol, you have a server. So generally in WhatsApp also, WhatsApp is like a broker which connects people. So which is like a server in between publisher and subscriber. So here also you'll have broker. Broker is nothing but an entity which is a server which is connecting both publisher and subscriber. So topic is nothing but in WhatsApp you will be having a mobile number, right? If you want to create a WhatsApp account, then obviously your mobile number is very important. So that mobile number is called a topic on which your mobile device is connecting with WhatsApp. So your mobile application is connecting with WhatsApp server based on the mobile number, right? So that is a topic. So when you have a server, obviously you'll have a port number, because port number is very important. So MQTT brokers will have a common port number called 1883. So 1883 is a default port number. And broker is nothing but a place where your server is running on. So here, as I said previously, there are some open source brokers, or else you have your own private broker also. So you can have public broker, you can have a private broker. So broker is nothing but a server, a place where your server is hosting. So that will be the IP address of Raspberry Pi if it is hosting on Raspberry Pi. If not, if it is hosting on cloud, so their IP address will be the broker IP address here. So when we talk about applications, so there are various applications and use cases, something like smart home, smart city. Everywhere you see, if you have a communication, you can use MQTT protocol. So MQTT is a lightweight communication protocol. In many places, people use it. So let me give you a brief outline how this happens.
Okay, say you have a temperature sensor. Okay, so you have a temperature sensor. Say you have a temperature sensor which is installed inside the room. Okay, you want to pass data to greaser. Say you have a temperature sensor which is installed in the room, and you have a greaser inside the washroom. Say so that temperature sensor wants to communicate with greaser. So what happens here? That greaser will be subscribed to the temperature sensor. So say instead of computer and mobile device here, so you have computer and mobile device here. Instead of computer, let's assume that you have a greaser which is acting as a subscriber for temperature sensor. Then what happens here? Temperature sensor will keep posting data to broker. So if say this broker is hosted on IoT gateway, so if it is hosted on IoT gateway, what will happen here? Temperature sensor data will be sent to the IoT gateway. Then what IoT gateway do? IoT gateway will pass the data to greaser. So because greaser is subscribed on the topic called temperature on the that is connected with broker. So all the data coming from temperature sensor will be received by the end devices here. So for one topic, for one publisher, you can have multiple subscribers here. So you have a temperature sensor, and if the temperature sensor data is needed for AC also, so you have a common temperature sensor connected in your room, and the temperature sensor data is needed for geyser, it is needed for AC, and it is needed for fan even. Say if a fan wants to automate itself based on the temperature sensor, say if your room temperature is very low, then obviously the fan speed should be reduced enough, right? And also AC. So the all these devices, all the smart devices will be connected to the temperature sensor. So whenever the temperature sensor data is pushed, then obviously all these devices will kept automated accordingly. So there you can use this kinds of IoT gateway, and all these devices which are inside a room will be you can easily control them, right? So one can control the data. So that's the important point which I wanted to highlight. So MQTT communication to produce. So data is transferred, you can make a decision making loop. Say so and so data is received, you can make this, you can switch to the actuator, you can make your actuator on, rotate or whatever. So based on the target. Okay, so that's what MQTT, a brief outline, because as time is a constraint, so I have to be very fast. So this is a simple, brief outline on MQTT protocol. Let's use this MQTT protocol in the programming context. So let me share my screen of my terminal. Okay. So this is share screen. So let me jump into the practical stuff. So I will share all these programs, okay, to the coordinator. So he will be sharing all these files to you. Let me put everything into the same folder so that there will be no confusion. So let me show you how to use MQTT communication for late, and slowly we'll jump into controlling of them. So let me start with communication first. Okay, so let me create a program, sudo space nano space. So before I create a program, let me tell you that if you want to implement MQTT communication, you need a library. Okay, so let me share browser. So there is a library called PAHO. So there is a library called PAHO versus. Yep. There is a library called PAHO. So you can. So PAHO is a team who is maintaining MQTT protocol on Eclipse Foundation. Okay. So PAHO, you can able to see PAHO is an IoT project for MQTT protocol, for implementation of MQTT protocol. You can able to get this data. eclipse.org/PAHO. Okay, so this uses so there is a library called PAHO MQTT. So using this library, we can able to get the data between the devices. So generally, it is mainly used in IoT use cases rather than WhatsApp kind of thing. Okay, so it is mainly used in IoT. So you can able to see here MQTT So under PAHO banner, open source client libraries for MQTT are being curated. And there are already MQTT C, Lua and Python and C++ and JavaScript. So these are the different types of programming languages that are supported by PAHO MQTT protocol. So we have Python, so well and good. So we have to install this library. Okay. So this library is not a built-in library with in Raspberry Pi. We have to install that library. So let me jump into the command prompt. So to install that library, you can install any kind of library right away from the command prompt, and the command is like sudo space sudo. So morning I have explained this. Sudo space pip3 space install space PAHO -MQTT. So this is the package which we have to install it on the command prompt. Sudo space pip3 space install space PAHO -MQTT. Enter. Okay. So password. Okay. So it's saying requirement is already satisfied. If not, it will get downloaded and it will be installed. Okay. So as of now, I'm having this package with me on my laptop, on my Raspberry Pi laptop. So you have this, requirement already satisfied. So it means that your package is already there. If it is not there, then it will be, downloaded and it will be installed. Okay. So as of now, it is there. So PAHO-MQTT. This is a package name. Now let us create. So I have installed this, so it's already there. So let me, create a Python program for sending and receiving. Because if you want to make a communication, so you should have a sender, you should have a receiver, right? So let me write both programs, sender and receiver first. And so the context of controlling device here. So sudo space nano space MQTT. So is my shell visible to you? Sudo space nano space MQTT underscore pub.py. Space tell. So is my audio fine? Can you check my audio? Okay. So my screen is also visible, right? So let me start scripting the task. Let me import the library here which we have installed. Import space PAHO.MQTT.client. So this is the package which we have installed, which is PAHO.MQTT now. So instead of using this entire name, we can rename it as EM. Okay. And also let me import time libraries here. Okay. So step one, I have to import libraries. So these libraries will help you out in accessing the protocol. Okay. So the first library is like PAHO.MQTT.client. So this library will be existed on your Raspberry Pi only, when this library is installed. So we have a time library, which is a built-in library. So here, what I'll do is I will create a client object to connect with broker. So we have to create a client object to connect with broker. So the syntax is nothing but client equal to m dot capital C client. Okay. So you need a client object, right? So objects constructors are very important. So these objects will try to connect with broker. Okay. So you need a client object. So you need a client instance like the broker. So here we have to create a client object. So once a client is created, we can connect with broker. Step 3 is nothing but you have to connect with broker. So when you connect with broker, you can able to transfer messages. Okay. So client dot connect. So client.connect, client is object which is created in the step 2. So step 3 is nothing but, using that object, we have to connect with the broker. So the broker is broker.hivemq.com. Okay, so this is a broker. So which I have shown you, broker.hivemq.com, and port number is 1883. Port number is 1883. So this is a default port number. So here, let me write, if broker is connected, let me write broker connected. Okay, so broker is connected. If broker is not connected, it will show you an error. Okay, so this is a step 3. So what we did here, we have imported the packages, and then we have created a client object, and then we have connected with broker. So by using .connect method, so that connects with broker. So we have to pass some arguments, and the first argument is like, broker.hivemq.com, that is a broker URL on which we are using now. So this broker.hivemq.com is open source broker, anyone can use it. Okay, but if you want to use it in the production stage, you have to purchase a license. As of now, in the free license, so we can use this for prototyping and all. So now step 4 is like, you have to read data. You have to read data from user. So in Python, generally in C programming language, we have scanf. So scanf is a function which reads the data from, a user, right? So here also you have a function called input. So let me data from input, okay, from user. Say let's write k equal to input of enter message. Okay, so what is a message that you want to enter? Okay, so that message it will read. Input is a function or a statement which reads the data from user. So that data it will store in k. So this k I wanted to send. Okay, so this k I wanted to send. So step 5, send this message to subscriber, isn't it? To receiver. So the method is like, client.publish of. So when you're publishing data, you should talk about to whom you want to publish. So say here in IoT, we have in MQTT protocol, we have a topic name. So let's have a topic name, something like MadBlocks. So what will happen? The people who are subscribed to this MadBlocks will be able to get this message. So what is a message? Which is nothing but K. Because we are storing the message in K, and that message will be published, isn't it? So these are the simple 5 steps which you have to implement for implementing MQTT protocol. Okay, so in the step 1, what we did, we have imported libraries, and then we have created a client object to connect with the broker or to publish. You need a client object. So if you want to, access all these things, we need a client object. So after creating a client object, we have connected with the broker. So client.connect broker.hivemq.com. So 1883. So 1883 is very important. This is a default MQTT port number. And then we have printed broker connected. And then we have read the data from user by using input statement. And then we have published this data. Okay. So this is a program of publisher. So let's exit from this. Control X. Y enter. So any queries in this program? Do you have any queries in this program? Let me see if you have anything. Just put in the chat. Okay. So here we have this program. So no questions asked. We have this program which is like so which publishes a message. So let's exit from this. Okay. Let me open a new tab. Okay. So let me open a new tab. Let me write subscriber program. So as of now, I just wanted to demonstrate both publisher and subscriber on the same Raspberry Pi. Okay. Generally, what happens is the other device should be able to receive it, right? So that place we have to write subscriber program. So now on the same Raspberry Pi on 2 different terminals. Okay. On 2 different terminals, I'll be running subscriber program here and publisher program here. Okay, let me create a subscriber program also so that these 2 devices can able to communicate. Okay. So here let me import the same library which is imported for publisher also. So let us write step 1. Step 1 is like, you have to import libraries. You have to import libraries here. What libraries? One is like, import paho.mqtt.client as yum, and the second library is like, import time library. So we have to import these libraries in the step 1. In the step 2, same as publisher, we have to create a client object. We have to create a client object so that you can able to access the other methods. So here client equal to MQTT dot capital C client. So this is a mistake which people do because capital C here it is. Okay, so that's a method which is defined in PAHO MQTT library. Okay, so we have created a client object. Step 3, we have to connect with broker, isn't it? So to connect with broker, same as publisher, client dot connect. So dot connect is a method which connects with broker. Broker.hivemq.com, and port number is 1883. So 1883 is a default port number. And then step 4, you have to subscribe, right? So this program is a subscriber program. You have to subscribe for what? For Mat blogs, isn't it? Because that is a topic which we wrote in publisher program. So here, client dot subscribe of Mat blogs. So on this topic, whatever the messages are transferred from publisher to subscriber, all these messages will be received by the subscriber. Okay, but whenever subscriber gets a message, it has to notify, right? So something like WhatsApp. Always we cannot open WhatsApp application and see whether messages are received or not, right? So whenever a friend puts a message on WhatsApp, you will be notified with a notification, right? So that notification service is very important. Whenever you get a Gmail, you will be notified on the desktop, on the home screen, right? So whenever you get a Facebook, say whenever you get a Facebook request, you will be notified on the home screen. So notifications are very important because always you cannot sit 24/7, looking at the WhatsApp, right? So you have to be notified. So here also there is a concept of notification. So what we have to do is we have to create a service kind of thing, which is a notification service kind of thing, so that the device gets alerted. So let me define it. So def notification. So we have to create a notification function. So this notification function will be called only when subscriber gets a message. So whenever you get a message, so you'll get a notification, right? So we have to pass 3 arguments here. One is called client object, and second one is user data. So data of the user who messaged you, and message. Okay, message caller. So these are the 3 arguments which we have to pass. So we have to print the message, right? So we have to print, message. So message is an object. Okay. So every object will have key value pairs. So if you remember, the data type called dictionary in Python. So there is a key value pair concept. Okay. So we have to access a key of which your message is being stored in the MQTT server. So there is a key called payload. Okay. So there is a key called payload. So we have to access that payload. So generally in rocket science also you'll have a concept called payload. So what is rocket doing? Rocket is a carrier, right? So you will have a payload. So payload is the actual information that you want to put in, right? So here also you have a concept called payload. Payload is nothing but the actual information that is put in the message object for transferring the data. Okay. So that message I wanted to print. So this notification function should be configured. So we have to configure. So how to configure this? When to configure this? So whenever you receive a message, so whenever subscriber receive a message, then this notification should be called. So there is a like client dot message equal to so configuring the notification function here. So step 6 is configuring the notification function. So which is like client dot on underscore message equal to notification. And the step 7. So always keep a point in mind. Your WhatsApp application will be running on the backend, right? So though you don't open, but you'll get a notification because your services are running on backend. So that is why your battery will be consumed, will happen, right? So battery consumption will happen because all your applications will be running on the backend. So though you don't open it, for example, say you'll get a Gmail. So you'll get a Gmail notification, though it is not opened, right? So it will be running on the backend. So you have to run the subscriber also. You have to run the subscriber on the backend. Okay, so which means that you have to repeat until you have to repeat the you have to wait and repeat the logic. This subscriber gets a message, right? Forever. So loop underscore forever is nothing but, you know, a function which is iterative until you stop the program, until you kill it. So people will be putting, if battery is less, will be putting in low battery consumption mode, right? If you put in low battery consumption mode, what will happen? So all the applications which are running on the backend will be killed enough, right? So here also, so we have something like, you know, loop underscore forever. So what loop underscore forever will do? Loop underscore forever, the name itself says your logic will be iterative enough. So it is forever until you stop it. So this logic will be executed. What logic will be executed? It keeps waiting for publisher messages. Okay, so this is a subscriber program which keeps waiting for publisher messages. Okay, so let me exit from this. Okay, so we have two programs here. One is publisher.py and the second one is subscriber.py. So let me run the subscriber program. Sudo python 3 mqdt underscore sub.py. Okay. So it is yum. Okay. So because we have written yum here, so that is yum.clear. Okay, so that is error. Anyways, let's run the subscriber program. Python 3. Okay. Sudo python 3 mqdt underscore sub.py. Okay, let me run python 3 mqdt underscore pub.py. So broker connected, enter message. So what message I want to enter? Say make light on, whatever. So that is a message which I want to send. So you can able to see the same message received with the subscriber, which is like, you know, make light on. So make light on is nothing but a message which is transferred by the publisher, right? So publisher is sending a message called make light on. Okay, so again, let me send one more message, make light off, enter. Okay, so this message will be received by the subscriber here. So what subscriber is doing? Subscriber is receiving all the information which is sent by the publisher. So what is happening here? Your publisher is sending data to broker. So it is connected with broker. So it is sending data to broker. So what broker is doing? Broker is broadcasting the data to all the subscribers connected on the same topic. So what is the topic which we have connected? Mad blogs. So Mad blogs is a common topic where publisher and subscriber are connected to it. Okay. So they are communicating on a topic called Mad blogs. So that is why you can able to see a message called make light off. So any doubts here? So any doubts here? So this is how you need to communicate in between, you know, publisher and subscriber. Okay. So now let me jump into Arduino. Okay. So let me write an Arduino program. So here we are just communicating the data, right, in between, you know, a publisher and subscriber. So let me write a program for Arduino. So let me stop my screen and let me share the Arduino screen. So Arduino, so this is a morning program. So let me create a new file. Okay. So here, let me write a simple program. Okay. So here, let me connect a device. Okay, say int, say LED equal to 13. Okay, so say then LED connected to 13 GPIO on Arduino. Okay, so let me, you're able to see it, right? Int LED equal to 13. Pin mode, LED is an output device. Okay, so LED is an output device. Okay. So we have to start because Raspberry Pi is a gateway. Okay, Raspberry Pi is a gateway where the devices are connected to Arduino, say a controller kind of thing. So here let us start with serial. Okay, let us begin the serial communication. So 9600 is a baud rate. Okay, 9600 is a baud rate. So here what I wanted to do is I wanted to make this LED on and off based on the data which is transferred from MQTT protocol. Okay. So initially what happens here is like, we void setup is nothing but one time executable. So this will be executed for only one time. Okay. So once it completes executing the setup, it comes to loop. So loop is an iterative loop in Arduino. It keeps iterating there until you stop the power supply. Until you disconnect power, so your logic will so what I will do is I will wait okay until unless Raspberry Pi serial dot available which returns the number of characters available to read. So what is serial dot available? So serial dot available will count how many number of characters are there to read. So as of now 0 because Raspberry Pi is not instructing any data. So serial dot available will return 0. So what is while of 0? When 0 false, what will happen? It will skip from here, right? But it should not skip. It has to wait until data is available to read. So that is what I'll do is I'll write simply not. Okay, because not 0. So not 0 is always true, right? Because 0 is always false, not false is always true. So here what I'll do is I will stop the compiler. I'll stop the compiler or the controller, whatever, until Raspberry Pi instructs. Okay, until Raspberry Pi instructs. So when Raspberry Pi instructs, what will happen? It will send some data to Arduino. If some data is available, what will happen? It will return true. What is not true? Not true is nothing but false. So it will skip from there. So you can say that there is some data available to read. Okay. So we have to read the data. Okay. We have to read the data. Say, while of serial dot available. Okay. While of serial dot available. If data is available, what will happen? So this condition will become true. Okay. This condition will become true if data is available. Okay, so this is called blocking statement initially. So this is called blocking statement. Always keep a point in mind. Blocking statement will have a semicolon at the end. So this blocking statement will block until Raspberry Pi instruct a message to deliver. Okay. So when Raspberry Pi sends a message, so it will skip and it will go to the second while loop. In the second while loop, what happens is okay. So char ch equal to serial dot read, or you can say serial dot read string also. Whatever, serial dot read string. Okay, or simply if it is read string, we have to create a string. Okay, string m equal to. Okay, so we have to compare. Okay, if strcmp, okay, string comparison m comma, say you have say LED on. Okay, if both are equal, what will happen? It will return 0, right? So if both are equal, if m is also LED on, what will happen? String comparison. So if both are equal, it will return 0. So that is why what I'll write is not. So always I prefer not, because a not 0 is always true. So here what I'll write is I'll make the device on. So if you want to make the device on, digital write of LED comma 1. Okay. So when you put LED comma 1, so that LED will be on. Okay. So else if strcmp of m comma, say your task is LED off. Okay, so your instruction is LED off, say then not in front of it, because when LED off is received, this will become 0, but we have to make not 0 is true, then only will enter into else if condition here. So here what I'll write is digital write of LED comma 0. So here what happens here is your LED will be off. So whenever you receive a command called LED on, your LED will be on. Whenever you receive a command called LED off, your LED will be off. So you are using which instruction here? Digital write. What is digital write? You are assigning logic to LED. So what is LED? LED is nothing but pin number 13. So to pin number 13, you'll get high and low logic. So based on the instructions received by Raspberry Pi. Okay, let me upload this program. So let me click on save and let me upload. Cannot convert string to const char star. Okay. So let me take some size, okay? Char gamma 15, whatever. ME. Okay. So there is a data conversions. Okay. Let me do one thing. Okay. So done compiling. No issues with the code. There is a problem with okay. If it is permission, we have to give instruction to the sudo chmod a plus rw #tv ttysmc. So on Raspberry Pi, everything it will ask permission. Okay, so that is the problem. Yes, done uploading. Okay, let me check with the serial monitor. LED on. Okay. What is this? Okay, 1 second. Let me. So instead of it is creating a problem with bytes. Okay, so let me simply pass some instruction in terms of single characters. So serial.read is nothing but it is like a, okay, it is like a and it is like b. So we can pass any kind of instruction. So it is creating some problem in terms of bytes in serial monitor. So permission denied. If it is permission denied, I'll show you what you have to do. So where is this share screen? So generally on Raspberry Pi, if you are opening Arduino, so this is a command which you have to run. So sudo chmod a plus rw. A plus rw, I mean append plus read write onto the port DEV TTY ACM0. Okay. So when you give this permission, you can easily upload the data. You can easily upload the program onto the Arduino board. Okay. So let me do that. Okay. So everything is fine. So how to show this? Okay. I'll put in front of the camera. Okay. Okay, let me share my screen again. Where is this? So let me share the serial monitor. Morning also someone has asked me to share the serial monitor. Okay. So hope the serial monitor is visible and Arduino, where is this? Yes. I don't know whether it is
Visible, sir.
visible. Okay. So on the serial monitor, I'm pressing A. Okay. So you can able to see. Okay. You can able to see the orange color LED is on. And LED is here. It is on. Okay. I'll press B. Okay, B is nothing but an instruction to make that LED off. So there is no light here. Okay, you can easily differentiate. If you press A on the serial monitor, that LED will be on. Okay, some light is on. So when you press B, that LED is off. Okay, so when you press A, like this, on the serial monitor, so serial monitor is for debugging. Okay, so whether your LED, whether your logic is working or not. Okay, so let me jump back to the Raspberry Pi. What is this? Okay, let's stop sharing my serial monitor. Let me share my what is this? Yes. Okay, let me share my command prompt. Okay, so let me write the program. So let me create one more program here to control this device. Let me write sudo space nano space. I'll write Arduino device, okay, or you can say Arduino LED.py. So let me write this program. So import space serial. So morning also we have imported the same package. We have to create a serial object with a COM port number /dev/tty SEM0. So that is a port number assigned to this Arduino. 9600 is a baud rate and timeout signal is 0.5. So if there is any disconnection, it will connect again. So after this, we have to pump data. So let's write, let's import time. Okay, let's import time. So let's say while true. Okay, let's say while true. Let's say k equal to input of enter command, okay, to instruct Arduino. So this is a test program. So let me do it for you, and let me compare. If k is equal to say LED on. Okay, if k is equal to LED on. So then what I have to do is I wanted to write a. Okay, elif. So in Python, else if is called elif. Okay, k double equal to LED off. Okay, then serial dot write of B. So we are passing this data to the Arduino through serial port. Okay, and then time dot sleep of 2, which means 2 seconds of delay. Okay, let me run this program. Control X, Y, enter. Sudo Python 3 Arduino LED.py. Okay. What did he saying? Syntax error. Okay, I forgot to keep colon, I guess. So colon is mandatory. Okay. Control X, Y, enter. Now let me run sudo Python 3 Arduino LED.py. So enter command to instruct Arduino. So let me write LED off. Okay. Unique codes are not, please encode. So it is asking me to encode. Okay. So you can see that. So let me encode. Okay. What is this? Sudo Arduino underscore LED.py. It is asking me to encode. So let me put this way. Can I use this? So let me check that. Okay, let me write LED space off. Okay. So it is taking some time. Enter command to instruct Arduino LED. Okay, let me stop it. Let me check Arduino underscore LED.py. Okay, let me print. Okay, so print command instructed to make LED on. So in the similar way, let me also do that. Print command instructed to make LED off. Okay, so that we can understand. Sudo python 3 Arduino underscore led.py. So let's type led space on. Okay, it is not entering into okay, so it is not encoding the data, I guess. So let me do it this way. Okay, let me check whether it is entering into this or not. So let me write hi so that let me check whether it is entering into the loop or not. So generally just enter LED space on. So it is entering into the loop, but it is not encoding the data properly. So let me do it this way. So here what I'll do is say, let me put this way, m equal to a, okay, m equal to dot encode of UT5 and 8. So this is the encoding standard. So now I will send this m, okay. In a similar way, because it is asking me to encode data, so m equal to p, m equal to m dot encode of UTF-5 and 8. So that is the encoding standard that always Python 3 prefer. Serial dot write of m. Okay. Now let me exit and check this. Okay. LED space off. Oh, yes, there is some problem. Let me check it out. LED space off. So that data is not sending to Arduino. So there is some problem with serial communication. Okay, let me check that.
Madhu sir? Madhu sir?
Okay. So there was a problem with Raspberry Pi. My system was restarted. So let me share my screen. Okay. So this is what we are trying to do, right? So it was just restarted. So I was testing this code. Okay. So you can see my, hope my screen is visible and my audio is also audible.
Yes, sir. Screen is visible, sir.
Okay. Okay. So this is Arduino, which I connected with the Raspberry Pi. Okay. So let me send this commands like LED space on. Okay. So when I hit enter, you can able to see your LED, which is on Arduino, is on. Okay. So LED space off, enter. Your LED is off. So your Python program is able to communicate with Arduino. Okay. So here manually I'm just entering LED on and LED off, but the target is like, the publisher has to publish data. So it has to done by publisher, not by user manual, right? So let me stop this program for a while. Let me jump into, two shells. Okay. So one is like, a publisher, second one is subscriber. So here let me jump to publisher program for a while. Sudo space nano space mqdt underscore pub.py. So in the publisher program, what I'll do is enter message. So here what I'll enter is like, LED on and LED off from the publisher program. So there is no issue here. So let me jump into the Arduino LED program, because Arduino LED program is a tested program. Okay, so it is just a testing program. So what I'll do is I will integrate this Arduino LED program into the subscriber. Okay, so instead of while true, so morning also we did the same thing. Instead of while true, what I'll do is I'll just write a function def send to Arduino. Okay, so which what I want to send, so say I want to send k. So let me remove this. Okay, because this k has to be transferred from the from the publisher. So if publisher sends LED on, so your LED should on. If a publisher sends LED off, your LED should off. So this publisher can be from any place. So your device is in Japan and you are in Hyderabad. Say you want to transfer your message, you can do that. Okay, because our broker is hosted on the cloud. So if it is hosted on the cloud, you can access the device from anywhere across the globe, right? So, okay, what is function name? Send to Arduino. Okay, so let me open subscriber program for a while. Sudo nano mqdt underscore sub.py. So in the subscriber program, what I'll do is I'll import that Arduino program here. Okay, so import Arduino underscore LED as a. Okay, so here what I'll do is I have to decode this message. Okay, so let me store this message in a variable called t and let me decode it. Otherwise, you'll get error, because all the messages are encoded and decoded. Subscriber is a receiver, so we have to decode it. And now here what I'll do is if, or directly I'll send this. Okay, so a dot, what is the function name? A dot send to Arduino. Okay, a dot send to Arduino. Okay, so what I want to send, I want to send t. Okay, so t will be received, t will be assigned to k and the k will be compared. Okay, so everything is fine. So let me exit this one, control X. Okay, so let me exit this one also. So let me print t. Okay, for me to understand. Control X, Y enter. Okay, so let me run publisher program here. Okay, subscriber program here. Let me run the subscriber first. So always subscriber should first. Okay, so always subscriber program should run first. Sudo python 3 mqdt underscore sub.py. So your subscriber is ready. Okay, now let me run publisher program. So sudo python 3 publisher program .py. So enter message. So let my message be LED space on. Okay, so that message will be received here. So LED on. Okay, so let me rerun the program. Let's say LED space off. Okay, so again that message will be sent to here. Your LED is off. Okay, so here let me show you the Arduino for a while. Okay, so this is one LED is always on, that is a power LED. Okay, so let me put my finger so that it will not distract you. Okay, your LED is off as of now. So let me enter, LED on. Okay, enter message. Let me put LED space on. Then immediately your LED should on. So there is a light on here. Okay, so let me send a message called LED space off. Okay, your LED is on, which means that the MQTT publisher is sending data to subscriber. So what subscriber is doing? Subscriber is sending data to Arduino. Okay, so we wrote 3 programs. Anyways, I will share all these files so that you can also do this at your end. But as of now, let me tell you a simple thing like publisher can be anywhere, subscriber can be anywhere. Okay, this both are communicating through broker. So where is broker hosted? Broker is hosted on the cloud, which is broker.hivemq.com. So the topic name should be same. If the topic name is same, they can communicate with each other. If they can communicate, you can control it. Okay, through the Python scripts here. So if you want to use the same thing in the mobile app, in the Play Store, Play Store, there is a mobile application. Okay, so there is a built-in application for MQTT protocol in IoT. So let me tell you that name. So you can also test it out. So there is a built-in application. So no need to develop it. So let me tell you the name so that you can also test it. IoT MQTT panel. So 4.4 is a star rating for it. Rahul Kundu, he is the person who developed it. So IoT MQTT panel. Okay, so in IoT MQTT panel, you have to download the app from the Play Store, and you have to install the app on the mobile phone, and just configure the broker and topic. So what is the topic here? Mad blocks is the topic. You can have any kind of topic. Okay, topic always mad blocks, so you can put any topic. Okay, make sure that your subscriber is running. Okay. So if you put mobile phone, what happens here? If you put mobile phone, your mobile phone will be acting as a publisher. So what will happen here? This application will send data to broker. Where is the broker? Broker is not hosted on Raspberry Pi. It is hosted on the cloud. So cloud, the broker which is deployed on the cloud will be able to receive your message. And once the message is received, what will happen? It will broadcast to all the subscribers who are subscribing on the same topic. Okay. So the publisher, so who is publisher? Your mobile phone. Say if you want to control your device from the mobile phone. So your mobile phone will be acting as a publisher, and that sends data to broker. Broker will broadcast the data to subscriber. Who is subscriber here? Your Raspberry Pi is a subscriber, because Raspberry Pi is connected with Arduino through USB port. So your subscriber is Raspberry Pi. So Raspberry Pi will get the data, and that data will be, a little decision making is happening here. So once it understands the data, then it will pass the instruction to the Arduino. So we wrote almost 4 programs. One is like publisher, second one is subscriber, and third one is Arduino LED program. And also we wrote a simple C++ program on Arduino. So we wrote 4 programs for this use case. Okay. So application, you can download it from Play Store. Okay. So that's all about controlling the device through MQTT protocol. This is what I wanted to share. So let me little discuss about the last use case. I will also share that information. So let me share my browser. Okay. So it was closed. 1 second. So hope you are aware of Google Colab. Are you aware of Google Colab? So I'm using Google Colab for doing machine learning analysis. So it was there on my Colab drive. So let me open it. So I just wanted to show that because time is running. I guess time is up, I guess. So let me show you that thing so that it will be good enough so that you can also test it. So I wrote this code just a couple of weeks back in order to demonstrate the use case. So let me share my window. So, okay. So this is Google Colab. Okay, Google Colab is a collaborative Python notebook where you can deploy it from your Gmail account. I don't know whether you are aware of it or not. Google Colab, which is collab.research.google.com. If you have Gmail ID, you can create an account. Okay, I will share this also with the data set. So I have a data set. So let me open my data set. Okay, so it is in downloads. So I took the data set from the Kaggle. Okay, so Kaggle is very popular in terms of data science. So I took this data set from Kaggle source. Let me show you the data set so that you can also understand. So I took the data set related to the parameters like, let me share. Okay, stop share. Share screen with the data set. Okay. Okay, can you able to see the data set? Okay, so this is a data set. One is like, there are temperature columns, there are humidity column, there is pH, there is rainfall, and there is a label. Okay, so which indicates that, so what will be the, temperature, humidity, pH, rainfall. So when you provide this kind of inputs, okay, so average temperature in the field, average humidity in the field, average pH, average rainfall, then it will start recommending which crop you have to yield. So we have different types of crops here. We have almost 24 different types of crops. I will share this data set with all your emails. Okay, so you have the certain ranges of temperature, rainfall, humidity, pH. So the better crop the farmer can yield when they have this kind of data. So here we have different types of data samples. Okay, so I collected all this in order to demonstrate, a use case on agriculture front with IoT plus machine learning. So there are a lot of data. There are almost 3,000 plus data. Okay, so there are almost 3,000 plus data samples. Ranges from different types of crops. Okay, so there is average temperature, humidity, rainfall, and pH. So when these parameters are given, because in IoT, all your sensors will keep collecting the data, right? When sensors keep collecting the data at one point of time, what will happen? Your data will be stored in the cloud. So daily, if you keep reading the data from temperature, you can calculate the average temperature, right? So you can calculate average temperature per day. You can calculate average temperature per week, per month, and per year, right? You can able to get all those data analytics on the data when the data is getting stored. So when you pass the data to this machine learning model, then immediately it can start suggesting what crop can yield. Okay, so that is the data set which is available right away with me. So let me upload this data set to my Google Colab so that a machine learning model can build. Okay, so let me stop sharing my data set. Let me share my screen. Okay, so here let me upload this data. So I have to click on the folder icon. So this is the like temporary file storage. So it is now connecting with Google Compute Engine. So this Google Colab is little bit free up to some extent. Okay, so it has CPU and also GPU support. Okay, let me upload this data set onto the Google Colab. So is this crop data set. So this data set will be uploaded onto the Google Colab. Okay, so we have a package. We need a package called Flask Rock. So this is like binding the local IP address to the dynamic global API. So that anyone can access. You can access my server with the help of global API. So you have to run this. Okay, so you have to. I will share this file. You have to run this. When you run this, what will happen is, this package will be installed on your Google Colab. Okay. Now the package is downloaded and it is installed as. Now here, what I am doing here is, the data from the data set. Then I'll be able to apply, K&N classification algorithm on the data set. So based on that, I am preparing a model. So once a model is ready and trained, then I can pass the input data. Okay, from the temperature, humidity, rainfall, and all. Okay, so here what I'm doing is I'm importing the packages. Okay, so this is a step which I'm importing the packages, which is Pandas. Pandas is nothing but a popular data science package which is used to read data from CSV file. Because we have data from the dataset file, we need to read the data appropriately, which is like in a certain format. So that is why I'm using Pandas, and also numerical Python library for numerical manipulations. So I'm using a popular package in machine learning, which is like scikit package. So this scikit package will have all custom libraries. Okay, so that is why no need to write from scratch. So today you have to import the library and you have to call the respective functions. So the task will be done on the back end, right? So all these things are built in Google Colab. So Google Colab is very popular in machine learning and IoT and deep learning projects. So people use this because the support on the laptops will be very less, right? So generally people have 4 GB RAM, average laptops, but here on Google Colab they will support up to 12 GB of RAM. So that is why a majority of people use this because it will be a bit faster when you compare with your laptops and all. So all these packages. So I guess I have used decision tree. I guess what is this? Yes, I have used long back. I've written this. So I have used. Yes, decision tree. So I have used a decision tree, regressor. So in order to predict, what kind of crop can be yielded here. So here, what I did is like, I have imported the respective packages. So one is test underscore split. So this is like, your data set has to be, when machine learning is concerned, we have to split the data set into two pieces. One is like, training data set and testing data set. So that is why this package is imported here. And standard scalar. Standard scalar is very important if in data pre-processing stage, because in data pre-processing stage, I always say 4 quick observations. Okay. So the first observations is like, when you look at the data samples. So here, if you see this, I don't think this is shared. Okay, let me share it. So when you look at the data set, you can easily understand why scaling is needed. When you look at this data, so we have 87.474, okay, in one column. In the other column, you have 6, which is very pretty less. In the other column, you have 111, which is pretty more when you compare with 6. So we have something like, 6, 111, 87, 18. So which means that there is no proper difference, right? So there is no proper, relation between those values. That is why what we'll do is we scale them. If you have a certain scale for all the element, for all the data samples, if you have a certain scale, then it's easy for us to, predict the data there. So that is why I'm using a standard scalar method. So standard scalar method is very important. Before you create a model, okay, we have to bring them on a scale, on a common scale. All the data entries will be on a common scale. So here I'm using standard deviation method. In the standard deviation method, the scale will be in the range in between -3 to +3. So thereby, it's easy for us to make some, training models and all. So that is why I am importing standard scalar method. And also I'm using decision tree. So in decision tree, it is easy for us to, identify or recommend, which kind of crop can be yielded there based on the, algorithm of decision tree. So I guess sometime later I'll explain all this in detail, but as of now, as a time constraint, so I'm just, explaining all this code. So accuracy and score, which is used to understand what is accuracy of the model which is being trained. So Flask, I'm using this Flask framework in order to create a web user interface so that the user can enter all the data. So what is average humidity or average temperature or average pH, so average, all this data, we can enter through web user interface. Once data is entered, it passes the data to the machine learning model, and the machine learning model, it keeps suggesting what kind of crop can be yielded there. So here I have listed out the crops that are available in the data set, like wheat, mung bean, tea, millet, and all. So all this are the data associated in the crops, okay, in the data CSV file. So here what I'm doing here is, I'm reading the data from CSV file, and then I'm just repeating all the dummies, okay? Because when you look at the data set, price is duplicated several times. Wheat is duplicated for several times. That is why what I'm doing here is I'm just identifying all the duplicated labels, okay? I need a unique label. Wheat should not be replicated again. Banana should not be replicated again. So that is why what I'm doing here is I'm just converting. This is a data pre-processing stage where I'm encoding all the categorized data into a unique mathematical values. So that is why there is a function called pd.in pandas. There is a function called get underscore dummies, which encodes all the data, encodes all the data into numerical values. That numerical values will be appended to the data there. So after that, what I'm doing here is I'm just identifying what are the dependent variables and what are the independent variables. So when you look at the data set, label, crop is a dependent variable, whereas the remaining are independent variables. So humidity is an independent variable, temperature is an independent variable, rainfall is an independent variable. So all these independent variables will be stored in X and dependent variable will be stored in Y. So after that, I'm just splitting the data set into train and test. After that, I'm just bringing everything into the scale of -3 to +3. After that, I'm creating a classifier object, so which is by using decision tree mechanism. And then I'm just training the data by passing X train and Y train. I'm just training the data on the classifier by using decision tree. After that, I'm just predicting it. So by using dot predict method, it predicts all values of Y. Okay, all values of X. So immediately Y will be generated. So we have Y predictive here. And then I'm just calculating the accuracy score. Okay, if the accuracy score is more than 70, then I can start increasing my data set so that it will be good enough. So in order to predict the manual values, so I'm creating a Flask framework here. So let me import one more HTML file, which is like crop.html. So in Flask framework, so what we have to do is we have to create a new folder here. So we have to name it as templates. So inside templates folder, we have to upload HTML file. So this file also I will share it. So this is a Bootstrap HTML user interface. So if you're from computer science background, you can easily understand Bootstrap. So this HTML file will be holding a form data. So let me show you that. Let me upload a crop.html. So that is the file. So the crop.html will be holding the HTML user because front end and back end. So what is front end here? Front end is HTML form. So in the front end HTML form, we have to enter all the data. So that passes the data to the back end. So on the back end, you have a machine learning model, and that machine learning model will be able to predict. So that data, it will be forecasted to the front end. So here you can able to see, whenever you call this, IP address, so immediately crop.html will be reflected onto the front end. So whenever they post data on the form, that data will be collected here, and that data will be sent to the predict mechanism. So in the predict mechanism, it will try to calculate the score. So based on the score, it will try to identify the crop, and that crop output will be shown to the user in the front end. So let me run this so that you can understand. Let me run this program. So I'll share this Google Colab notes. You can able to check it out. If there is any doubt, okay, you can reach me on my WhatsApp. I'll share all my details so that even after the FDP or SPTP session, so you can use this ngrok URL. Okay, so this is a dynamic. It will always changes from time to time. So when I click on it, so it has to redirect to the front end. Okay, so this is a form. So what is this form? So this form is nothing but form data, sensory data. Let me enter some data. Okay, 20.8, 82.7, 7.8, 202.8. So this is data. Now this data, when I click on submit, it will pass data to okay, there is some error. What is the error? Okay, there is text here. Okay, just a minute. So everything is done. Let me check back again. Oh, that's small bug. Okay. So let me enter the values again. Rainfall to submit. So it will pass data to backend, and the backend will start predicting the data. So that data, you can able to see it here. It is showing. So when you have this kind of temperature, humidity, rainfall, okay. So you can, it says that papaya can be can be yielded in the the given temperature ranges there, temperature, humidity, rainfall, and all. So this data will be passed to the user by creating several user interfaces here. So it's a demo kind of thing, right? So farm data will be posted to the machine learning data. Machine learning will predicting the data. That data will be it is showing here. So anyways, I'll share this file. Okay, please go through that as time is up. Okay, I cannot explain deep dive. So any queries you can ask me in the chat. Let me jump into the chat. So thank you for being with me from morning. So if you have any queries, you can post in chat. Okay.
Participants, if you are having any queries, please put it in chat box or you can raise your hand.
So if you have any queries, so I will share all the programs and PPTs also to the coordinator. So this sir will be sharing all these files to you. If you practice all the stuff, if you get any question or error, you can WhatsApp me on this number. So 789301562 or you can push a query on iot@matblocks.tech. So thank you all. Thanks for joining me.
Sir, one question is there, sir.
Okay.
If I want to teach a course on IoT application, what are the programming languages to be taught to students?
Programming languages in the sense, if you want to start from Arduino, because Arduino is a microcontroller, right? So if you want to start teaching from Arduino perspective, then you have to share, embedded C++ programming. You have to taught embedded C++ programming language and also Python. So if you want to develop the complete end-to-end application, Python and embedded C++ will help you out. Use any microcontroller. So Texas Instruments also uses C++ concepts. So I guess embedded C++ and Python will help you. So any other doubts?
Yes, sir. Prashant B, sir. You can ask the question, sir.
So data science and IoT are like siblings. Okay, so both will be together for a lot many years, because IoT, IoT is all about getting the data from end devices. Okay, once the end devices pushes all those data at one point of time, you have to analyze and understand the data, right? So data science is all about understanding the data and providing several features. So from data use. So today we have EC, CS department, but I think I don't have a department. You have a data science department. So all the in the science you'll have all mixture. Okay. So I don't think so. Engineering will be again will be converted into domains. So data science and IoT they are together always. So but in many colleges and places, people put two different prospects for IoT and data science, but for me, everything is integrated. Okay, IoT, data science, artificial intelligence, everything is integrated. If you want to become smart, so IoT plus AI. So when you look into AI, it's all about understanding the data. When you keep understanding the data, obviously intelligence is built. So any other queries?
Participants, any queries, you can just post in the chat box or you can raise hand. Madhu sir, excellent session, sir. So it was a great experience on Python and Arduino. Practically, you showed n number of things, so that it is and now challenge for us to practice all those particular things and make our students to be well aware about all those things, sir. Thank you so much, sir. All the day from morning at 10 o'clock up to now it is around 4 o'clock. So you take a pain on for us, you made so many programs and you showed all those particular things, sir. Thank you so much, sir, for your valuable time which is spent with us and sharing your knowledge with all of us. Thank you so much, sir. And all the participants throughout since beginning, sir, they are saying that very informative session, very nice session. Today's session is very good. So these are all the comments which you have received since in the morning session, sir. So thank you so much, sir, for your valuable words. And now Rajendra Madhu sir said wonderful, sir. So thank you so much, sir. Thank you for your time sparing with us. Thank you, sir.
Thanks for inviting me again. Because it was always because I am with Good Level Engineering College for the last 3 years, I guess. Because I did a lot of boot camps with EC department in particular.
Yes, sir.
Thanks. Thanks for calling me, sir.
Yes, sir.
It was wonderful time today having with you all.
Yes, sir.
Please practice well so that because training a faculty is more important, because if you train one faculty, it's equivalent to training 5,000 students.
Sure, sir. Yes.
Sharing of knowledge is very important. So thank you all for joining me today, having me here. So I wish you very good luck. Thank you. Bye.
Yes, sir. Thank you, sir.
Bye, sir.
Yes, sir. Dear participants, so tomorrow will be the last day for us. So please see that tomorrow from 10 o'clock we will be having the first session, and there will be 3 sessions for tomorrow. And one more thing is after 3:30 the third session is completed. We will be having a valedictory function first, and after the valedictory function we will be having the quiz, so which is a compulsory for all the participants, and you should score 60% in the quiz, whatever is been kept for tomorrow after the valedictory function. And all the questions will be multiple choice questions, and you will be having 20 questions, and you should write all the 20 questions, and the time given is 30 minutes, and each question carries 2 marks. The questionnaire, so 20 questions, each question 2 marks, and the time is for 30 minutes. So I request all the participants to attend that particular exam, and 60% of marks is a must in that particular exam. So that will be posted in the Google form after the valedictory function, and you will be given 30 minutes to write that particular exam. And one more request from all the participants. So tomorrow we'll be having a valedictory function. So in that valedictory function, so I request the participants to give your feedback on this particular workshop. So which is mandatory kept by the AICTE people. So I request the participants to share your views, to share your feedback in that valedictory session. So thank you, sir. Thank you all for your patience. So I hope the attendance link is also posted. So please fill that attendance, and let us join for the day 5 tomorrow at 10 o'clock. Thank you, sir. Thank you, Madhu, sir.
Yeah. Thank you, sir.